This is a very common type of ratio problem on the test. They say that you've got 3 runners in an 1800 meter race, and they race in segments of 3 to 2 to 1. How long in meters is the shortest segment? Well, what you do is you say, I want to find the factor that inflates or decreases this ratio. When they give you a ratio and the total, that's always what you're going to be looking for in the SAT. You got to find that factor. Well, I've got 3 to 2 to 1. We're going to say x is the factor I'm looking for. So I've got 3x plus 2x plus 1x equal 1800. 6x equals 1800. X equals 300. So the shortest distance would be 300. If they wanted the middle one, that would be 6. And the longest would be 900. This is a difficult question of the question type that is very common on the SAT. This is one where they give you a ratio and then they give you the total. In this case, they say 3 pods contain 14 peas. The peas are arranged so that the ratio in each pod is 4 to 2 to 1. What's the least number of peas moved to accomplish this? Normally, they want to know what the factor is that inflates or decreases the ratio. See, we have this ratio of 4 to 2 to 1 and a total of 14 peas. We want to find the factor that increases or decreases that ratio to get you the total. Well, if I set it up, x is going to be that factor. I've got 4x plus 2x plus 1x equals 14. 7x equals 14. X equals 2. As an aside, usually they'll want you to fit that factor back into one of those elements of the ratio, for instance the 2, to find out what that represents. 2 times 2 would be 4. There'd be 4 peas there, for instance. But in this case, this is a harder question. They want to know the least number of peas moved to accomplish this. Well, we want 4 times 2 plus 2 times 2 plus 1 times 2. That's the ratio we're in to get to our 14. Well, I've got 14 peas. Okay, if I move 2 off, that gives me my 1x, or the 1 in my ratio. And then if I move 4 off, I get the 2 in my ratio. So I'm moving 6 peas, the 4 and the 2. One of the ways they like to ask ratio problems is by putting parallel lines within a triangle, creating similar figures, similar triangles. Remember, parallel lines create similar or proportionate triangles within a triangle. In this case, they tell us that W, X, and Y are equally spaced on line B, and W, V, and U are equally spaced on line A. If WY equals 16, and WU equals 24, and XV equals 10, what's the perimeter of the quadrilateral UVXY? Okay, they're equally spaced. So this tells us that XW equals XY equals 8, because we divide that 16 into 2 equal segments. We're going to divide that 24 into 2 equal segments and say that WV equals VU equals 12. So we've got this proportion set up. Knowing that these are equal, we're told that XV equals 10. Well, XV and YU would be in the same proportion as the others. So what we do here is we say 8 is to 10 as 16, the bigger line, XY, is to YU. Cross multiplying 8YU equals 160, we see that YU equals 20. You could also shortcut this by saying the ratio that we're in is 1 to 2. Now we just want to add up what we've got. We've got YU plus UV plus VX plus XY. Well, YU is 20, UV is 12, VX is 10, and XY is 8. They total 50.